Some of y'all may remember, but last year we did our Mecubator project where we used Rev parts like rails or control hubs, expansion hubs. We used that to automate an industrial sized excavator. And we thought that was pretty cool, but we want to do something even bigger. So we automated an 18-ton RV. Hooray. Okay, moving on.
So, Rev Robotics does not claim this project. First, does not claim this project. We assume because they're reasonable people. And we don't claim this project. Our team, Iron Rain, does not claim this project. Our school doesn't claim this project. We as people don't claim this project. And the world doesn't claim this project. Don't do this. Do not do this. Please.
Okay, so even while we were doing this whole thing, we still had safety as our priority. So the whole time, our coach, who is the owner and operator of the vehicle, was the only one who could start putting gear and accelerate the vehicle, and he could also manually press the brake or the emergency stop button right there. It's actually right here too. And we also designed a braking system that is supposed to act passively instead of actively to allow for any uh, cover-ups for any accidents or such.
So this is our site, and if you can see the area that is in blue outline is our coach's house where we operate. And this is far higher in elevation than the little white oval, which is the place where the R2V2 or RV operates. And the yellow line over there is where the R2V2 cannot go because it's blocked off by steep cliffs and also trees. And the red lines are very, very steep cliffs where once again the RV cannot go. And on top of this, we also have the safety precautions that we are taking, such as, like Chris said, our coach always remains in the driver's seat, and all of our precautions are detailed in our blog post over there, and that's linked to the QR code.
So part of our development process so far is we have done a ton of work on our safety. So we've implemented our many safety features we talked about before. We've also put together our autonomous driving or not, our non-autonomous driving, so teleop with a game controller. And yeah, so
It's not clicking.
oh wait. Okay. So yeah, and as I was saying, our current plan is yeah, we have finished our safety for this, so it is perfectly safe to operate. We have our braking system fully functioning, so we can unbrake is what this is called. We unbrake the brake. We can steer using a mounted thing onto our steering wheel on the RV. You can see right there. And we have remote teleop drive using a gamepad fully over Wi-Fi. So yeah, and we are currently working on getting vision-based tracking with a camera mounted on the RV and GPS-based driving so we can do it autonomously.
So here we have our two controls, our steering wheel and our braking mechanism. So for our steering wheel, what we have is we have a plywood base attached to our steering wheel, which then has a worm gear and a motor attached to it, which can control the steering wheel using remote control. And the paddle that you see on that steering wheel there is used to mount the worm gear and motor and make it stationary so the actual physical steering wheel can move.
And as for the braking system, can we show this to them? Okay, so we'll go into the specific parts of it in a bit, but the main concept of the whole thing is that this pedal right here is going to always be on the brake pedal to make sure nothing happens with bungees and stuff. But it can lift off of the brake pedal, allowing the RV to, while in drive, move forward.
Okay, this was our first prototype for steering. It was essentially a piece of plywood and a sprocket and a chain mounted on top of that sprocket. It was pretty cool in theory, and then it started breaking down as we worked on it. What happened was, can you go back a slide? Back. Yeah. Oh wait. Okay, but essentially it was a piece of plywood and a sprocket on top and a chain on top. There was no comfortable way to mount the sprocket on the chain, and there was a bunch of physical logistics that didn't really work. And yeah, we ended up moving on to prototype 1.5.
So for this prototype, we use a strap and buckle clasp system, right? That's right there to attach to the steering wheel. So this buckle, this strap actually goes around from the back of the plywood all the way to the front, where it meets this clasp system will pull it into place. We also use a series of screws to guide it into the steering wheel. So finally, what we decided was what you see here. It is a worm gear attached to a motor. It's on the plywood cover that's on the wheel, which kind of mimics the form and keeps it in place. And yeah, as we said before, the paddle is what we use to mount it.
So this is our assembly, and you may be wondering why we've taken so many complicated steps. One of the main goals of this project is that we don't permanently do anything to the actual RV. So everything we have here, including our braking mechanism and our steering, it's entirely detachable quickly so we can drive the RV normally to get from point A to point B. So for steering assembly, what we have here is we have a carbon fiber plate, which we CNC'd and milled ourselves. And we use one end of it, the smaller end, to attach the shaft collars onto the plywood steering wheel. And then we attach that to the worm gearbox. And then we have the other part of the carbon fiber plate, which attaches onto the worm gearbox and onto the paddle, which then keeps everything stationary inside our RV.
Okay, so it's a bit of a funky picture, but we had to disable our airbag, make sure no one gets hurt, right? So yeah, as you can see, it's there's the heavy steering automation assembly is like right on the airbag, right? So that obviously had to be disabled, so nothing happens. This is our calibration sequence.
So what it's doing there is it's spinning the wheel all the way to the right, and then it's going until that motor stalls, which is when it hits its rightmost bound, and then it's going all the way to the left, and then it finds its leftmost bound, and then that ends up mapping to your gamepad where I can pull the joystick to the right a little bit, and it'll move just a little bit, and we have now range limiters on that so that I won't be running the motor into the end of the range of mode.
And it also has a sanity check at the end of the calibration to ensure that our encoders are working, because we did actually find when we were connecting our encoder cables, we had to do some extensive connection with them, using some wiring, that they were not always perfect. So when the encoder cables fail, we actually just cancel our calibration to ensure we know where the steering wheel is, because it is really important that we're driving in the right direction.
So, can you go fast?
How do I go back?
Uh,
Got it. No,
one more. One more. God.
I'm not doing anything.
Forward,
My hands are off.
one slide. There you go. Okay. So our initial idea was actually to manipulate the brake and acceleration directly using a system of pulleys. But the problem with that system was that we needed a automatic safety measure. So we needed the brake to automatically want to push down on the brake. So we came up with this design, which is it uses a pedal mechanism which acts as a foot to actually press down on the brake. And this is attached to bungees that consistently pull the foot down on the brake unless it is released by the motor. That way, if there's a disconnect or something bad happens, the system will automatically brake, and so we don't just go careening off into a cliff. And this all fits under this fits on the dashboard, and then this fits under the seat, and it has really quick installation. Okay, so this is the actual construction of the whole unbraking system. So we made it out of rev rails. This is something that you could actually theoretically do. It's not out of reach for most teams. Yeah, so there are two bungees that are attached to the front side of the pedal that go towards the end, all the way back. That's for all of our tension. That's what keeps the pedal down for the most part. And passively, since it's tension, it's always applied. So unless it's actively pulled off, it's always pressing the brake. Yeah, so the brake is on an axle, which uses a pulley system and a gear all the way back here. The string is attached, it's elevated on a triangle. You know, triangle is the strongest shape. So, haha, it's a little fun fact. But that is attached to the back of the pedal. That is what actually pulls the pedal off, which disengages the brake, and if the RV is in drive, you know, it goes forward. And yeah, we also had to elevate that string because there was no way that was gonna actually pull the whole what uh 15 gear ratio. That was gonna there was no way it was gonna pull up, so we gave it a little elevation to make it easier. Okay, so this is an action. I am quite literally attaching the battery to the motor, which is not these cables. Um, yeah, so that's kind of what it looks like. That's kind of like a demo. Yeah, in theory, that's what it's supposed to look like. Okay, this is coding.
Okay, so the way that this works is by default, because there's bungees pulling down on the we call it the counter brake because we have a habit of naming things really badly. So we called it the counter brake. And by default, the bungees are pulling down. So all we need to do, in theory, if anything's wrong, is to turn off the motors, and these are all back drivable, so they just go down. No issue. And then we have a dead man switch, is what we call it. It's a person with another gamepad that has to be constantly holding down a button to make sure that the main driver is actually paying attention. This is because we are still high schoolers and we get distracted very easily. Um, yeah. So I as a main driver, I have to pull my right trigger, and somebody on the dead man switch has to be holding down that switch for it to actually come up off the brake and for it to move forward. So yeah, this is the RV driving around. I'm sitting in the passenger seat. That's really hard to see. I'm sitting in the passenger seat with a gamepad controlling the whole thing. It's kind of surreal.
So, so our future plans are to add a dash webcam so that we can control the RV autonomously and have it track certain objects. And we also want to add precise GPS RTX so that we can control the RV with centimeter level precise GPS. And we also want to test on a larger course. Right now, we are literally testing in our robotics coach's backyard in a giant pit that we have for supposed to be a warehouse eventually. Um, so we're trying to move to a larger course so that we have more freedom. And also, since this will all be working autonomously eventually, we want to work with mobility assist companies to accurately and appropriately use the system.
So we very, very, very specifically said, don't do this. Please do not do this. But we're not saying not to do it because it's out of your realm of possibilities. We're saying to not do it because you can do something better. We did all of this with Rev Parts. So with your experience as robotics team members and robotics coaches, you can make far more incredible things using just the things you have to build your robot. So go beyond what FTC tells you, go beyond the limits of FTC robotics and create something incredible because we're going to be the future and you should start it now. More questions?
Any questions?
I have no questions online. Any questions in person?
Wonderful. Oh, yeah.
What part of Dallas should we live?
It's technically not Dallas because our coach lives in Duncanville.
Dallas.
Oh, Dallas. Okay. It's not very south.
Yeah, because that's where I think some kids have trees in the elevators.
Theoretically, we're going to be using this to actually like use it as a mobile lab for people. So just don't come to Dallas at all if you want.
Don't go outside.
Don't want to come to Dallas. We're gonna come. We're gonna try things to the state. We'll look at automate our house. So it's not necessarily close, but the parking lot around the development said that it'd be plenty of room to try it and.
Lots of cars to wreck.
And secondly, I'm appreciating your work with us. It looks very familiar. Very familiar. Very familiar. Thank you.